Hello everyone, this is Dr. Shiva Ayyadurai. Today I'm going to teach you the 9 elements of every system in the universe, including your body, or for that matter, any system. You know, I've used the word system a lot. You hear the word being used by pretty much everyone in the world. The system is rigged, or the healthcare system, or the transportation system, or the biological system. But rarely are you really taught in a very simple way what a system is and what are the elements of the system. So in the next few minutes, I'm going to teach you the 9 elements of all systems, how these 9 elements interconnect, and how they actually work in a very practical way, not only in your life, but also to give you a perspective on how to understand and look at pretty much any system in the world, in fact, every system in the world. And the reason this is important is that once you understand these principles, you can actually start figuring out the real problem in a situation and what the real solution is, and then how you actually go about fighting to implement it. So it's going to be a video that I hope is really going to stay with you for a long time. It's a skill that you're going to learn. So I'm very excited to share this with you. So let's begin. So first of all, I'm going to start with the 5 elements of every basic system in the world. And then we're going to go into the 4 additional elements which make it what I call an intelligent system. And by the way, there's a book I have called System and Revolution. Here's a copy of it. You can get it online, or when the video ends, there'll be ways that you can order. But it gives you the fundamentals of all systems in the universe, but it also teaches you what change is and what revolution is from the standpoint of systems thinking. So let's begin. So every system has one fundamental element called an input. The input is what comes into a system, which I'm going to represent here by this. Initially is this dotted line, and you'll see why I'm putting a dotted line on it shortly. So stuff comes into a system, and what comes out of a system is what's called the output. Okay, that's the second element. The third element of every system, and this, now I'm going to make this darker and shade it in with or bold it here, the thick line, is the structure or the storage element. I'm going to use the word storage and structure interchangeably, or structure. So what do I mean by that? The storage or structure is a thing in which the system itself is contained in. So if you think about, if you made oatmeal this morning, the stuff that you put in are the ingredients. The bowl that you put it into is the storage element of those ingredients. It's the thing that provides structure. And when you're done, you empty the bowl to get the output, which is probably hopefully a nice, warm, delicious bowl of oatmeal. One of the important other elements of a system, there's 2 other elements in the basic system, is the aspect of transport. Call this transport. So this is the aspect of stuff coming in and stuff going out, both transport. By the way, a system's inputs can be matter, which is physical objects, can be information like bits and bytes, or it can be energy like magnetic or electricity, those kind of things. So the input comes in, it gets transported through the system, and it goes out, and it's contained in a structure. Now the 5th element of every basic system is what I like to call the conversion element. And I'm putting it in this form because the stuff that comes in can undergo conversion. Okay? Thicken that line a little bit there. So there you go. Those are the 5 elements of every basic system. Input, output, it's contained within a structure. You have the aspect of motion, of things moving through that system, and conversion. So let's go back to the oatmeal example. You have your input, which could be your oats, water, maybe you even add some walnuts or some brown sugar. And then the conversion element of that system is the fire, the heat that you put in. And that heat converts that raw ingredients, based on how much water and ingredients put in, into something more gooey, something more cooked. The transport element is as you stir the oatmeal to get some consistency. And then the storage and the structure element, as I mentioned, is the bowl. Again, there's 5 elements when you make oatmeal. Very, very simple. Input, output, transport, the aspect of motion, moving through, conversion, the aspect of converting one form to another, and storage and structure. By the way, you can think about this on your own simple laptop. The input is a keyboard, the output is a display, the transport is the central processing unit, which converts the stuff that you type in. You put 1 plus 1, you get a 2 out of it. The structure and the storage is the memory, for example. If you have a hard drive, or if you put in a USB drive, but it's quite fascinating. You can apply this to an oatmeal. You can apply it to even even your computer. So those are the 5 elements of all systems. Now, what I just drew for you is actually called an open system, different than what we'll get to shortly, called an intelligent system. An open system, another example of it is, we have the lights here. I turn on the electricity, the input comes in, the electricity flows in. As the electricity flows in, it's transported to the light bulb. The light bulb converts that electricity into light energy, so you get the output is light, and it's stored within that encasing of that bulb. All right? So that's a open system because you're simply sending it an input and you get an output. Another example of an open system would be your water faucet. If you took a shower earlier this morning, you rotate, which is some rotation on that valve, which is the input. That then allows a flow of water through the valves, which before were closed, and then you get the output. And the water, was initially, if you're in your shower, it's contained in that shower. Okay, so there you go. So these are open systems, and we'll talk about from a bigger, sort of political standpoint. One could argue that those in power actually want open systems. They want to send you an input. They want you to simply provide an output. So, for example, advertisers, that's what they want. They love open systems. They put a picture of some delicious McDonald's hamburger out there. It goes into your sensory neurons, etc., into your brain. You convert that experience of that burger maybe to something you remember when you were a kid that was a very pleasant experience, and you run out to go get that, and that and that information is all coming to you through the television or whatever medium. So that's open systems. Now let's go to something that I think is much more important for you to understand. It's called intelligent systems. And once you understand this, you can actually start understanding in a very different way what is intelligence, what is artificial intelligence, and how this relates to you and pretty much every other system in the universe. And you can also decide whether you want to be an open system, getting inputs and reacting and giving output, or whether you want to be an intelligent system. So the important thing is these are 5 elements: input, output, transport, conversion, and storage. Intelligent systems have 4 additional elements, and these elements are critical to essentially creating intelligence. So what is the most important aspect of an intelligent system is what I like to call a goal. Okay? The goal, if you don't have a goal, or if even a man-made system doesn't have a goal, it's not an intelligent system. So things begin with a goal. And the aspect of intelligence is you set a goal. Let's say you have a goal for yourself. I want to graduate from college, or I want to lose weight. It's a big goal in this culture. Everyone wants to lose weight. So if your goal is to lose weight, you will measure, are you achieving your goal? Let's say you're 250 pounds, you want to get down to 150. So you want to lose 50 pounds. You'll typically use some type of device to measure, are you achieving your goal? So one of the critical things of intelligent systems, there's a concept called feedback. Some people call intelligent systems feedback systems. So in this process, you would take the output and you would feed it back. And by the way, this is the second element of an intelligent system. It's called a sensor. So in the case of wanting to lose weight, you want to go from 200 to 150 pounds. You would use a weight scale to actually measure what your actual output was. And then this would come back to you, and this would go into a very important, the third element of intelligent systems, or if you want to think about it, the eighth element of these systems, is a controller. Okay? So what happens is you set a goal. I want to lose 50 pounds. You actually look at the actual output, which you're measuring through a sensor, the actual weight scale. And this sensor feeds back the actual output back to your brain, which is known as the controller. So you have a central processing unit within you, hopefully we all do, and that controller is making a decision. Hey, my initial goal, I'm at 200 pounds, and the weight scale is saying I'm actually at 210 pounds. Let's say you actually had a big meal, and so you actually put on weight, so you're not achieving your goal. So what your controller would make a decision to say, I need to make some adjustments. I need to change the inputs into my system. So the controller would say, I need to not only lose 10 pounds, which I thought, but I need to actually lose minus 60 pounds. And it would send a signal, a decision it gets made here. So controller's responsible for making decisions. And the decision it would make here is perhaps to go on a fast. That could be an input. Okay? You say, I'm going to go on a 30-day fast, or I'm going to reduce my caloric intake for 30 days. And so that means the input into your system, you're going to change significantly. You may also decide to maybe exercise. And what this will do, or you may decide to add some spices to your foods. And what this will do is affect the transport aspect of you, which is you're moving more. Your digestion may improve. And your storage aspect in this case is your physical body, your bones and your fat, and you're going to affect those changes. And then you'll get a new output. Let's say after this, your weight actually goes down to, 160 pounds, right? And your goal was 200. So what are you're now 40 pounds away. So clearly, your goal was 150. Your goal was 150. You currently were at 200. So you say, wow, I'm doing pretty good. And so you may continue this path, okay? So you may continue this path. You may eat just salads all day. And you find out as you do this, now you're down to 140, okay? Your goal was 150. You've actually gone down. So you may say, whoa, I'm losing a lot of weight. Let me start putting some more protein, some more healthy fats. And you bring back your weight, and finally you get up to 150, okay? Now the point I'm making here is that this entire process, if you were to graph it over here, if I were to graph your weight here over time, your goal here, let's say, was 150 pounds. You started, let's say, over here at around maybe 200 pounds. And then you actually went up, as we saw. Then you came down. You went below your number. And then you came to your point. The point is, when you look at this graph here, and you may, go up a little bit, and you may come down, etc. The point here is, in intelligent systems, you set a goal, and your controller, which is you, is making constant decisions based on the sensor that it's observing, and it's affecting transport, conversion, and storage. These are elements within your body, and you can affect your transport element, your conversion element, which could involve digestion, your storage and your structural elements, which could involve fat storage, as you make these decisions. This is just a simple example of this. An airplane is another interesting example to think about. An airplane sets a goal to go from Boston to San Francisco. And I don't know if you guys know this, but an airplane is always 99% off course, meaning the autopilot. And the airplane is constantly looking at, maybe there was a wind, and it's constantly making corrections. The controller makes corrections to different aspects of the plane's input, which could mean the speed, the wing, arc, etc. And all of these things are affecting this process, but the goal of intelligent systems is to achieve their goal, okay? And so if you notice, I've talked about 8 of the 9 elements. And you can put this anywhere, frankly, but I'm going to call it the disturbance. All right? And just to review again, we have the input, output, transport, conversion, storage. This is the aspect of you within the open system. When you want intelligence, intelligence occurs when you set a goal and you observe the output using a sensor, and then you make decisions, okay? You have to have a goal. You have to have the ability to observe what's actually going on, not what you think is going on. Then you're making decisions using a controller. But the 9th element of all systems is also called a disturbance. And disturbances are interesting because you may have a goal, but you may have disturbance in your life. So for example, you want to go from your 200 pounds down to 150. Well, guess what? You may have some friends who really like partying a lot. They like going and getting wasted on Fridays and Saturdays and Sundays, drinking a lot of beer. That's one type of disturbance. You may not be able to find where you live good produce. That's another kind of disturbance. These disturbances occur, and what typically intelligence is how to avoid these disturbances, how to overcome these disturbances to achieve your goal. So again, let me just summarize. The goal of intelligent systems is to achieve their goal, and they have a number of important elements to be able to do that. We have a thermostat over there, and I give this example in the book, and you can see it also online. A thermostat, to give you another goal, and we'll wrap this up because I think you've probably gotten it here. Let's say the thermostat's goal is I want to hit 70 degrees, okay? So I'm going to keep the graph here. So my goal is, let's say 70. And in a thermostat system, what's really important is where you place the actual temperature, right? So in a thermostat system, in the basement, for example, I may have a hot water heater, okay? I'm going to put the hot water heater, which is storing hot water. This, in fact, I'm going to put it over here, okay? So let's say the hot water heater's here. And this hot water heater stores water. If I want to hit 70 degrees, and let's say when I start, the room temperature, we're actually here at this point here, okay? Let's say we're at 65 degrees. The hot water conversion process takes place maybe by some heat. I send in more heat goes in to the furnace, so I get more hot water coming out. And now the temperature, let's say, may go up to 68 degrees here, okay? So now I'm at 68, and the controller would say, please continue to let more hot water in, and this may, let's say, go to now 72 degrees, okay? And at that point, we would shut off the hot water. The control would say, stop giving me hot water, and then the temperature may drop down to 69 degrees, in which case we'll send more hot water, so it went to 69, and then eventually we may hit our goal of 70 degrees. We're attempting to modulate around that goal. So one of the key principles that you learn when you look at this, and by the way, if you want to look at disturbance, a disturbance could occur if I put the thermometer, which is the sensor here, let's say that thermometer was near the window, and I left the window open in the winter. Well, what would happen is that would be a disturbance, because a room would actually, it would be getting the wrong temperature. That would actually be much cooler than what is actually going on. So in case of a disturbance like that, either you can move the thermometer to a different part of the room to capture a much better understanding of the room, or you close the window. So this is basically what's called control system. Understand this, take a multi-year course at some engineering school, but you basically learn what a control system is in the last few minutes. So anyway, this is Dr. Shiva Ayyadurai. I just want to let you know that these are the 9 elements of any intelligent system. I'm going to do a series of these lectures so you can really understand what a system is. But the most important thing you need to take away from this is not only these 9 elements, but intelligence is not about simply setting a goal and then waiting for things to happen. Intelligence is you set a goal, and you have to commit to that goal. What this graph here teaches you is about commitment. It's not about perfection, because the reality is we're never fully ever on target, but the idea is, are we committed to making changes in the midst of disturbances so we achieve our goal? Look, if you want to get in great shape, or you want to achieve a certain diet, it's hard to assume you're going to do it right every day, and it's okay to forgive yourself. In a system like this, the system understands that you're not going to be perfect, but the goal is, are you going to iterate one other time and one more time, and are you willing to make constant changes? And that is what intelligence is about. It's not about perfection, it's really about commitment. Anyway, this is Dr. Shiva Ayyadurai. By the way, this will be on YouTube shortly. You can sign up to you can follow us on Twitter at @VA_Shiva. There's a Facebook group called Truth, Freedom, and Health. You can join. It's a private Facebook group, and there's also a Facebook page. Check us out on Instagram. And by the way, this is a very nice book to read. I've consolidated probably 40 years of experience in the system and revolution. You can pick it up online. And by the way, I'm also running, as you know, for U.S. Senate. It's rare that a scientist and an inventor and a fighter all come together, but I am doing that. And my goal is to teach not only those in Congress and the Senate these principles, but also to teach you. And the fundamental goal here is we can really solve problems by identifying, we can figure out real solutions by focusing on the problems, and systems thinking is a way to do that. So I'm going to teach you this because I want to create more citizen scientists, citizen innovators, and citizen fighters. Anyway, thank you. This is Dr. Shiva Ayyadurai.